Problem 3, modeling and inverse variation. Your math class has decided to pick up litter each weekend in a local park. Each week there is approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. Well, take note, the park cleanup project, the top row is the number of students, N, 3, 5, 12, and 17, and the bottom row, time in minutes, T, 85, 51, 21, and 15. So as you might expect, as the number of students N increases, the amount of time in minutes to clean up, T, decreases. Part A. What function models the data? Well, step 1. Investigate the data. The more students who help, the less time the cleanup takes. An inverse variation seems appropriate. If this is an inverse variation, we'll let N times T equal K. From the table, N times T, or on a graphing calculator, L1 times L2 is almost always 255. So this seems to be a reasonable scenario for modeling with an inverse variation function. In step 2, we'll determine the model. As stated above, N times T, almost always, so for the purpose of this model, equals 255. Our model to represent the situation. Part B. How many students should there be to complete the project in at most 30 minutes each week? Well, we'll use the model from Part A, that's NT equals 255, and we'll substitute our value of interest, 30, for T, N times 30 equals 255, and solve for N, dividing each side by 30, N equals 255 divided by 30, and that's 8.5. So we can state there should be at least 9 students, because 8.5 students doesn't make sense, 9 students to do the job in at most 30 minutes. Your turn, Part A. After a major storm, your math class volunteers to remove debris from yards. The table shows the time T in minutes that it takes a group of N students to remove the debris from an average-sized yard. What function models the time needed to clear the debris from an average-sized yard relative to the number of students who do the work? In Part B, same scenario, but the question now is, how many students should there be to clear debris from an average-sized yard in at most 25 minutes?